everyone, how's it going today? Today we're going to start looking at acids and bases. Let's get into it. Today's video is going to be all about the basics of acids and bases. We'll look at what both acids and bases actually are and how to recognize them, at least in part, by their chemical formula. We'll then look at the different types of acids and bases. For acids, these are called monoprotic, diprotic, and triprotic acids, and for bases, they are monoacidic, diacidic, and triacidic bases. So what is an acid? You're probably at least a little bit familiar with acids from your everyday experience. We know that acids can be dangerous and cause chemical burns, but we also know that acids, like citric acid, are found in foods. The general definition of an acid is a molecule that can lose a proton when dissolved in water. Now, we've talked before in this class about how atoms cannot lose protons unless they're decaying radioactively, which is not the case for acids. What is actually happening here is that an acid loses a hydrogen atom, but they lose it in the form of a hydrogen ion, specifically a hydrogen cation. If you remember from our discussion of ions, cations are positively charged, and the only way to do this is to have one or more proton than you have electrons. Hydrogen is normally composed of one proton and one electron, but a hydrogen cation is effectively just a proton. You'll often see these hydrogen cations written as H+, and they are referred to as protons, hydrogen ions, or occasionally hydronium ions, though these are slightly different and depend on the context. Acids, as you may know, have a pH between 0 and 7. We'll get into pH in more detail next time. These are some examples of acids: HCl or hydrochloric acid, H2SO4 or sulfuric acid, and HCOOH or methanoic acid. Methanoic acid is written differently than a lot of chemical formulas because it is primarily used in organic chemistry. You'll notice that in all three of these cases they have at least one hydrogen atom. That said, having a hydrogen atom is not enough to make something an acid. For a molecule to be an acid, the hydrogen atom must be a part of a very polar bond. If you remember from our discussions on solubility and dissociation, ionic bonds tend to dissociate in water, so very polar bonds allow the hydrogen atom to separate into solution, which makes an acid. We often think of acids only in terms of their negative consequences, dangerous things like battery acid and acid rain, but acids also have a lot of uses and benefits. Citric acid is crucial to giving tropical fruits their distinct flavor. Stomach acid is key to breaking down food and housing the enzymes and bacteria that help with the digestion process. Sulfuric acid is used in batteries, fertilizers, paints, and pigments, and has a ton of industrial uses as well. And acetic acid, which you may know more commonly as vinegar, has uses in flavoring, preservatives, and as a cleaning agent. Now let's move on to bases. A base is often thought of as the opposite of an acid, and this isn't a bad way to think about them. A base is a molecule that can lose a hydroxide ion, which is a molecule composed of one oxygen and one hydrogen with a negative charge. Bases have a pH between 7 and 14, and are said to be either alkaline or basic. Some common bases include sodium hydroxide, NaOH, calcium hydroxide, CaOH2, and ammonium hydroxide, NH4OH. A lot of bases have names that end in hydroxide, though this is not always the case, especially with bases that have common household uses. Like acids, bases also have a lot of uses and benefits, though bases tend to be a bit more industrial than acids. Sodium hydroxide, aside from being a very common base for lab use, is used in the manufacturing of soap, paper, and some synthetic fibers. Calcium hydroxide is a cleaning agent, but it also has some uses in manufacturing. Magnesium hydroxide is an antacid, which helps with indigestion and heartburn. And sodium bicarbonate is better known as baking soda, which has unlimited uses within the household, at least according to Arm & Hammer. You all are probably too young to understand that joke. Oh well. There are different types of acids and bases, and each is divided into three major categories. For acids, these are monoprotic, diprotic, and triprotic acids. Monoprotic acids are acids that can lose one proton. Mono for one, protic for proton. A common example of a monoprotic acid is hydrochloric acid. Diprotic acids have two protons they can lose, and includes acids like sulfuric acids. Triprotic acids, as I'm sure you've guessed by now, have three protons to lose, and include acids like phosphoric acid. Now, included at the end are two examples of how identifying and categorizing acids can be a bit tricky based solely on their chemical formula. Glucose has 12 hydrogens, but it can't lose any of them. Glucose is not an acid at all. Methanoic acid, HCOOH, has 2 hydrogens, but only one of them, the one listed at the right, can actually dissociate, making it monoprotic. Interestingly, methanoic acid ends in OH, which could be interpreted to make it a base. It isn't, and generally speaking, if something is bonded directly to a carbon, it won't come off easily. Bases have a similar categorization, and somebody decided it was a good idea to call this classification the acidity of bases. Why? I can't think of any other reason than to be confusing, but oh well. Monoacidic bases can lose one hydroxide ion. Diacidic bases can lose 2, and triacidic bases can lose 3. Luckily, most bases will have a parenthesis around the hydroxide ion if there is more than one, which can help make it easier to identify. The number of hydrogen or hydroxide ions that an acid or base can lose does not determine the strength of the acid or base. HCl, which is monoprotic, is far stronger than H3PO4, which is triprotic. The strength of an acid is determined more by how easily they give up their respective ion, which is based on the strength of the bond holding the hydrogen or the hydroxide to the rest of the molecule. The weaker the bond, the stronger the acid or base. This is determined in part by the electronegativity difference between the atoms of whichever bond is breaking during dissociation. It is worth knowing that HCl, a common lab acid, is very strong, as is NaOH, a common lab base. Let's review. Acids are molecules that can lose a proton, in the form of a hydrogen ion, and have a pH between 0 and 7. Bases are molecules that can lose a hydroxide ion, or an OH-, and have a pH between 7 and 14. Both acids and bases can be extremely harmful, but both also have a wide variety of uses both naturally and commercially. Different acids and bases can lose different numbers of ions, resulting in 3 main classification groups for each. Acids can be monoprotic, diprotic, or triprotic, and bases can be monoacidic, diacidic, or triacidic. That's it for this video. Thanks for watching, and I'll see you next time.